For number 17, we're going to perform operations on functions. We're either going to add, subtract, multiply, or divide functions to make a new one, and then we're going to find the domain of our new function. For f plus g minus g and times g, the domain is just the overlap of the two originals. It's the intersection of the domains of the two separate functions. And then if you have a fraction, or if you make a fraction, for instance, f over g or g over f, you need to figure out what makes your denominator equal to 0 and then remove that from that intersection or overlap. F plus g means you are going to take your f of x and you're going to add it to your g of x. And that is equal to the expression for my f of x is 2x plus 3. My g of x function is 3 minus 5x. And then all I need to do is combine like terms. So that's going to be negative 3x plus 6. And my domain is going to be the overlap or intersection of the domain of the two original functions. The domain for both of these functions is all real numbers, or negative infinity to infinity. So they overlap everywhere, and the domain of your function, your new function that you got when you added the other two together, is negative infinity to infinity. Let's go ahead and do f minus g of x. That means f of x minus g of x. F of x is 2x plus 3. And g of x is 3 minus 5x. And to make sure that I subtract the whole function, I'm going to put parentheses around g of x. And then I have to distribute my negative, and then I'm going to combine like terms, and I get 7x plus 0, and once again the domain is negative infinity to infinity. It is just the overlap or intersection of the two original. Let's do f times g of x, which is just f of x times g of x. My f of x function is 2x plus 3. And my g of x function is 3 minus 5x. I need to use parentheses when I'm multiplying each of these functions together. And then we're going to end up having to FOIL. So I have 6x, then minus 10x squared, then 9, and minus 15x. And then I'm just going to combine like terms and put this in the right order. It's negative 10x squared, let's see, minus 9x, and plus 9. And then my domain, once again, is going to be negative infinity to infinity. It's the overlap or intersection of the two domains if it's f plus g minus g or times g. F times f, I'm going to take my function f and times him by himself. It is f of x times f of x. And that is equal to 2x plus 3 times 2x plus 3. And we have to FOIL that out. So we get 4x squared plus 6x plus another 6x. You can combine that right away if you want to. Plus 9. 4x squared plus 12x plus 9 is the final simplified version. And our domain is the overlap of my original functions, and f of x is negative infinity to infinity. And then the next one is going to be f divided by g of x, which is f of x over g of x. And my f of x function is 2x plus 3. And my g of x function is 3 minus 5x. So now we have to do a little bit of work here, because it's not just the intersection or overlap of the original domains of each of those functions. We now have a problem. We have x's in the bottom of a fraction. So what we have to do is figure out what makes that denominator equal to 0. So I'm going to just put my work over this side here because I don't really have a lot of room down below to do it where I probably should do it. So I'm going to put my work up here. I want to figure out what makes this expression equal to 0. So I'm going to subtract 3, and I'm going to divide by negative 5. You're going to have a negative divided by a negative, which is a positive, and then you end up with positive 3 over 5, and that is a value that x cannot equal. So our original overlap of our domains is all real numbers or negative infinity to infinity. That's the whole number line. But I am going to remove 3 over 5 because that is what makes our denominator 0, and we can't have that happen. So our new domain for our new function f over g of x is going to be negative infinity up to 3 over 5, union with the other side of that graph, which is 3 over 5 to infinity. And then we're going to do g over f, which is g of x over f of x. So we're going to flip that fraction around. You are going to have 3 minus 5x on top, and on the bottom you have 2x plus 3. Once again, the domain of the intersection of the two originals is negative infinity to infinity, but we now have x's in the denominator of the fraction since we've made a fraction, and we cannot have the denominator equal to 0. So I'm going to take my denominator expression and I am going to set that equal to 0, and I'm going to solve. I'm going to subtract 3 and divide by positive 2. And that's actually what x can't equal because it makes my denominator 0. So the original domains are both negative infinity to infinity, and the overlap is the whole number line. But now we're going to take back the 3 halves. So everything but negative 3 halves, negative 3 halves. If I said positive, I meant negative. Negative 3 halves. Everything but that is included in our domain, and that goes from negative infinity up to negative 3 halves, union with the other side, which is negative 3 halves to infinity.